Good afternoon, and thanks for joining our webinar. We're going to wait just a minute here or so to let everybody sign in, and then we'll get started here in just a couple minutes. All right, let's get started. Hello, everyone, and welcome. My name is Doug Iwichow, and I am a Marketing Communications Specialist at Testo North America. We have a great session for you today, Target Superheat using Testo Smart Probes and Digital Manifolds. To kick things off, we're going to go through a few logistical matters. Our session today is going to run roughly 30 minutes. We are going to have all attendees muted, but we encourage you to submit questions in the questions panel to be answered at the end. We are recording today's session, and we will send you a recorded version of the webinar afterwards via email. As a reminder, all attendees of today's webinar will be entered to win a brand new Testo 560i digital refrigerant scale and intelligent valve kit. The winner will be selected at random and will be contacted by email. Now for a brief introduction to Testo and our products and services. For over 60 years, Testo has stood for innovative measuring solutions. Testo helps over 650,000 customers worldwide save time, money, resources, protect the environment, ensure quality, meet regulatory expectations, and increase the value of their goods and services. Testo is a major supplier of monitoring instruments for markets as diverse as chemical, food service and production, pharmaceutical and biotechnology, as well as commercial and residential HVAC suppliers. Our speaker today is Leon Granger. For the past few years, Leon has been the Western Regional Manager for Testo's HVACR division and is currently transitioning to the Southeastern Territory. Leon has been in the heating and air conditioning industry for over 20 years in multiple markets. He received his Bachelor of Science from Lindenwood University in St. Charles, Missouri. Leon and his wife recently have found their new home in Florida and are currently enjoying exploring their new surroundings. And with that, I'm going to turn things over to Leon.
Thanks, Doug. I appreciate that.
No worries. Give me one second. You should be good.
Okay, cool. Well, thanks everybody for joining the webinar today. You know, the one thing I want to talk about, we're getting into superheat, subcooling, and targeted superheat is, you know, why do we test? And, you know, it really comes down to a few different things. Customer value. You know, the customer has purchased services from you, and they don't really know anything about the science and background of heating and air conditioning equipment. So they're putting their trust in you. So it's all about customer value, professionalism, right? This is a great industry to be in. You can make a lot of money doing this. It's very rewarding. Being professional and doing the right thing really makes you stand out and makes your company stand out. Safety, assuring that the work you're completing and doing is up to local regulations and OEM regulations as well as for safe operation. And of course, profitability, right? We don't do this for free. This isn't a charitable thing that we do. It's doing it to put food on the table and to better the companies that we work for. So that's really important to understand. Doug, do I have access to the keyboard?
You should try hitting it twice.
There we
There
go.
it goes. Yep.
Just a couple of definitions. We're going to kind of go back a little bit just to a little foundation where we start getting to targeted superheat. What is superheat and subcooling? Superheat is the temperature of a vapor above its saturation temperature at a given pressure, of course. Subcooling is the polar opposite. It's temperature of a liquid below its saturation temperature at that given pressure as well. And the saturation point, of course, is that temperature at which a refrigerant can no longer absorb or lose heat without change in state, meaning going back to a vapor or going to a liquid. So at a given pressure as well. Just kind of talking about why are superheat and subcooling important, right? So compressors are only designed to pump vapor. They're not a pump. They're actually a compressor compressing a gas. OEM manufacturers are typically going to put some wiggle room in the compressor to be able to handle some liquid, but they're not meant to handle liquid. So that's really important to understand. Superheat ensures that no liquid enters the compressor, and that's why we charge fixed orifice systems that way, is to make sure that we're protecting the compressor as we're charging that system. TXVs and EXVs, they need a solid column of liquid going up to the expansion valve, so we get that result that we want in the evaporator coil when it flashes and we have that pressure drop. We don't want vapor coming through that column at all. We want pure 100% liquid coming through. And that subcooling charging the systems ensures that and make sure that we have that and we get the reaction from the refrigerant, that chemical reaction that we want to happen. So just a kind of reminder, superheat, no liquid, subcooling, no vapor, and then saturation, you're gonna have a little bit of both and present in that situation as it's turning states. There's a couple of troubleshooting things here. Talking about superheat's too high, then typically that means that you haven't had enough refrigerant fed through the system, and you're getting poor refrigeration, excess energy use and things like that. So you're undercharged in that situation. When the superheat's too low, it's obviously you're possibly too much refrigerant being fed to the system, and you're overcharged. You could possibly getting liquid back to the compressor causing damage. So those are some things to think about. When subcooling is too high, we probably are overcharged, maybe a restricted metering device or something's wrong with the expansion valve. Subcooling being too low doesn't necessarily mean you have too little refrigerant, but it does mean that you have not lost the normal amount of heat through its travel through the condensing unit. So refrigerant charge. Charging by superheat and subcooling are the most accurate method. I know that some machines you're not going to be able to charge this way if you're having a unit that's attached to an inverter or a ductless type system, even a unitary system that has an inverter compressor. It's going to be difficult. All manufacturers are different, but most of them have different ways of charging a system. So it might be very difficult to charge a unit with an electric expansion valve, for example, to subcooling. However, most unitary equipment, this is the most accurate way to do it. In some instances, you may have to weigh a charge in the wintertime or when it's way too hot outside or inside the house. But again, charging to superheat and subcooling are the most accurate way to charge. So when do we check superheat and subcooling? Anytime you cut open the refrigerant circuit, whether it's a compressor, you're replacing the TXV, a line dryer, an accumulator, anything like that. Anytime the system doesn't appear to be cooling properly, you're adding refrigerant to the system. Obviously, you're adding a system to charge it properly. So those are the reasons you would do that. So just kind of going back, I know most people understand how to do this. We're going to talk about this to set the table to talk about targeted superheat. So going back to saturation for a moment to get into it, to get your superheat number that you need or that you're at the time, you can use your pressure temperature chart, and for that specific refrigerant, you know the relationship between pressure and temperature. So you're going to take that vapor side, the refrigerant circuit, your suction side, your vapor side, the larger pipe side, whatever you want to call it. You're going to take that operating pressure, and you're also going to take your surface probe temperature. You take that pressure and get your off the pressure temperature chart, get the temperature of that, and your surface temperature of your vapor line as well. In this instance, we're doing 410A. Your operating pressure is 140. It coincides with 49 degrees on the pressure temperature chart for 410A. You would subtract 49 from your surface temperature on your vapor line pipe, coming up with a 14-degree superheat. Okay, very easy to do, not very difficult. One second here. So after you get your superheat number, that's how you do it with an analog setup. Doing it with a digital gauge or smart probes through our smart app, it's extremely easy. We make it very easy for you. We even on our manifolds now, we have a meter sweep, as well as your evaporator temperature and your condenser temperature. You can look at your surface temperature, both high side and low side at the same time. You can look at your subcooling and superheat at the same time as well. Same thing in the app. So we make it very easy to do that. And we start talking about targeted superheat. We're starting to look at using a psychrometer or a thermal hygrometer as well to get that wet bulb, relative humidity, temperature. You can get dry bulb with these. They're very accurate. You can do load capacity tests with these. This is our 2nd generation version. Very accurate measurement to a 0.1 or a 1/10 of a degree resolution. Strong Bluetooth signal. Again, it's 2nd generation. We made these go up to 350 feet unobstructed. You could be in an attic and have this in the return plenum, and then be outside next to your manifold and have your dry bulb outside by the condenser and be communicating through the app or to the manifold, be able to get those signals. It's got a foldable head as well, so it makes it easy to put into a return or a metal plenum box to where it would stick to it. And if you're in a return air vent, it can connect to that very easy without falling out. They're very affordable and very accurate. The app that we use is 100% free as well, so just something to keep in mind. And then when you go to superheat on a digital manifold, it's really the same thing. You're hooking it up the same way. There's nothing changes on how you would do with the analog gauge. The thing that changes is just how the relationship between how you're getting your temperature, pressure, temperature chart, and how you're accessing that information. We have over 90 refrigerants in our app and on the manifold as well that you have access to those charts. You don't have to do anything with the charts. It's automatically done through the manifold and through the smart app. Okay, so you're going to do the same thing. You can look at the numbers the same way. You could have a pressure temperature chart there with you, but the computer inside the machine, inside the app, is going to do the calculation for you. Okay. So nothing, and, a lot of people that I talk to out there, they think that this is somehow or another hurting the industry because it is taking away the thinking of this. It is not taking away the thinking. If you're telling me that looking at a pressure temperature chart is some sort of very sophisticated thing, it's not. It's very easy to do. It's time consuming and you can have a human error. Looking back and forth through the pressure temperature chart as you're letting the system acclimate, you can make a mistake. The only mistake you can make with a digital manifold is just selecting the wrong refrigerant. Okay, so this is all about saving you time and taking advantage of technology that's there. So now you have a superheat measurement. So now what should you do? I mean, as long as you have a fixed orifice type system with a piston or capillary tube metering system, you can use, it's best to always use the manufacturer's charging tables. Always refer to the manufacturer's charging tables and what you need to do with a targeted superheat. Obviously with the TXV, you really don't, you're not going to be doing this. You may check your superheat to see how the expansion valve is working and everything, but you're charging by subcooling on these systems. Not to say that you don't look at your superheat, you're just not going to be doing a targeted superheat with a expansion valve type system. Some expansion valves are nowadays have a adjustable head to them, which still that's something that the manufacturer will tell you how to do. So we're not referring to this. We're referring to those older type systems or fixed orifice systems out there today. So this is, you can look this up. You can Google this targeted superheat formula. So the superheat measurement isn't enough because we need to know what it should be to determine if the system is operating correctly. This is really close to what most manufacturer charts will tell you when you're doing a targeted superheat, and you can't find the manufacturer's charging charts for targeted superheat. This will get you really close, within 1 degree, and that should be fine. Using the system specs supplied by the manufacturer will work, but also this formula works really well, which is your indoor wet bulb times 3, subtracting 80, which is universal, and then subtracting your outdoor dry bulb from that number divided by 2. So in this example, we have a 67-degree wet bulb times 3, minus that 80, and then minus 97, you would get, you come up with a 12-degree targeted superheat. Now the wet bulb and the dry bulb can be done with our 605i thermohygrometer. It will do all those measurements for you. Here's a picture of, I forget which manufacturer this chart came from, but at the top of this chart, I know it's hard to read, you're going to see a wet bulb reference, and you're going to see that dry bulb reference. So they're plotting this chart for you already. So in all reality, if you had this, you could actually do this manually if you wanted, and not even, and then you could look at the charging superheat on our manifold and do this. You could line this up based on the manufacturer, and you could do this as well based on that wet bulb and dry bulb from those thermohygrometers, and you can get the same result. However, we make it very easy for you if you want to use the formula that is embedded in our app, which is the formula that we talked about a few slides ago. So you would select targeted superheat on the measuring mode of the 557 or 550S, or through the smart app as well. You can manually input, or you can use live 2 605Is that are connected to the manifold. They will connect to the manifold Bluetooth, or you can do it through the app Bluetooth, and it will take those numbers. You'd select the 605i for the outdoor dry bulb by the condenser. You would select the 605i for the indoor wet bulb as close to the return as you can, and then it would automatically calculate that targeted superheat for you. Again, you can manually input those numbers as well in case you only have one. Then you'd get the number, you'd see what that number is, and you go in the manifold or the app and you'd plug that number in, and then it would calculate that targeted superheat for you. So if your actual superheat is too high, you'd add refrigerant. If that actual superheat is too low, you'd remove refrigerant, okay? Here's the screenshots of what it looks like this is actually the manifold screenshot, but in the app, it looks pretty much the same. So you get the screen, you get the measuring mode, you're gonna select targeted superheat on the left, and then you're gonna go over to configure target superheat, and it says outdoor dry bulb, and then return air wet bulb. You can do smart probe, or you can do manual input, and you can hit those numbers in. We have actually did a live test, so it's actually taking the smart probe here. I know it's in Celsius, but we get the drift of what we're trying to do here. And then as you look at the gauge on the far right, you've got your meter sweep at the top, looking at your pressures. You've got your evaporator temperatures, your condenser temperatures there. You've got your temperature 1, your pipe clamp temperature, okay, on your low side, and then your high side temperature pipe clamp reading. And then you have your superheat on the far left. In the far right, you have a subcooling number, whether it's needed or not, and then you have your targeted superheat there in the middle, okay? Pretty close. You may let this one ride as it is. And then you have your refrigerant there at the bottom, and that P equals 0 is a zero, you zero your sensor out on the manifold there. We have a new addition to the Testo refrigeration family, and it's the scale, the 560i refrigerant scale with auto charging valve. So that is a picture of it there on the right, and on the bottom we have it's just trying to signify that it can go through a wall. It's got a Bluetooth connectivity, both the charging valve and the scale. It works both with the manifold or with the app or with the smart probes, and it's backward compatible to our our generation of manifolds with Bluetooth capabilities. You'll still need the app with those to operate it. With the 550S and the 557S, you do not need the app. You can do just straight off the manifold, no problem. In the picture there to the right, it shows the guy on the manifold, and it shows the valve there. So you can auto charge by weight. So you can literally put the weight that you need for the system in the manifold or the app, and the smart valve is going to meter the refrigerant. It's going to pulse the refrigerant, I should say, to the unit. It'll stop when it gets to the weight that you've selected and then shut off. It will also do this with Superheat and Target Superheat with a correction or a safety feature. If you have a maximum weight that you do not want to go over, in case you can't hit that target that you want to get to, it'll shut it off at that. The same thing with subcooling. So the subcooling and Superheat, you'll need to have a manifold, you'll need to have the smart probes and things like that to communicate that information to the to and from the scale, so it'll know what those numbers are. It wouldn't work with another manifold. It has to work with Testo proprietary information. So we're pretty excited about it. It's available now. Great reviews on it so far. So the right tools for the right job. We know that both temperature and pressure are extremely important to do charging and doing these type of readings. So it goes without saying, it'd be an accurate, very accurate way to measure these pressures and temperatures. I can't tell you how many times I've been in the field with a thermocouple type pipe clamps that aren't calibrated, and they're off by a few degrees, and that makes a big difference when you're looking at a pressure temperature chart. You're looking at doing the math that goes with that. So we use an NTC type temperature surface temperature probe. It stands for negative temperature coefficient thermistor, and the thermocouples are what most of our competitors use. However, there are some resistive temperature detection systems out there as well. So on a negative temperature coefficient thermistor, what we use, if you look at the temperature range here, and then you look at the temperature range of a thermocouple, we use thermocouples in combustion because in combustion you need a much larger range of temperature. With refrigeration, we really don't need that temperature range. The NTC thermistor is what is good enough for our range. So if you look here, here's the range of a Type K a thermocouple, the RTD, and then the thermistor NTC. All right. You're looking at measuring range. You look at response time. You're looking at problems with stray voltage, accuracy, design, and price. The NTC is superior to all other temperature probes. Thermocouple is going to drift over time. In short term, you'll have high temperatures in your upper range. And then as long term goes, you're going to have much larger swings with that. A lot of people talk about offsetting. It's not really a calibration standard. And field calibration is a misnomer. I mean, it really should be field offset. The ice bath is a really crude way to do that. These need to be calibrated, or you just need to get a new one, a brand new one, and check those. Personally, I've checked the NTC thermistors that we use, a year and a half old in an ice bath, and they'll be right at 32 degrees. So they're right on. They're very accurate, very stable, no interference, and a quick response on that sensor. Okay, we offer it both in Bluetooth and wired for for our manifolds. Bluetooth, obviously, through the smart app. So we give you some options there in case you don't want the Bluetooth. Again, digital does it better. It's more accurate. It's definitely more accurate. Anybody that thinks differently, I dare them to take the test with it. When you do a leak check, when you do a leak check with our manifolds, you're going to see the leak right away with the way you can see the numbers, digital numbers on the manifold. calculates without human error, stays in calibration, highly reliable, rugged and durable as well. The apps are great for validation and reporting. You can do charging, troubleshooting, evacuation, recovery, pressure testing, targeted superheat, all through the manifold and the app now. Here's just kind of a lineup of our manifolds. You know, what comes with the manifold kits. Typically, you can get a wireless vacuum probe in most of the kits. Sometimes you'll have to buy that a la carte depending on the one that you buy. The 557 or the 4-port is going to come with either the vacuum probe 2 pipe clamps or the vacuum probe 2 pipe clamps and the hoses. So you have 2 options on that. The 550S, we have multiple options on it, and the 550i, we have multiple options as well. So great product. You know, the only other thing I'd point out is the vacuum probe that we use as well is a little different than our competitors. We're external. We don't have an internal sensor in our products anymore. We used to years ago. We found that warranty was difficult through the vacuum because if there's something wrong with your vacuum, you have to send the whole manifold in, like our competitors do. We decided that was not good for time and really not good for the customer. So we went external. External is also better for an accurate reading for vacuum. So if you're taking a vacuum and your sensor's in your manifold, you have to pull the vacuum through the hoses, and we feel like that is not accurate, and it's not going to be, it's not good to run the vacuum through refrigeration hoses. So running your vacuum through your vacuum hoses is really what you want to do. And we think that the wireless vacuum probe should be taken at the core removal tool or somewhere there close to the unit. That's where is the correct way to do it, and it's the right way to do it. It might not be the most convenient, but it's the right way. So leave that there. Doug, do we have any questions?
Let's see what we got on the panel here. That was really thorough, and I appreciate that. All those explanations. Let me see as far as questions. Just expand my window here. Just trying to read the one here. Is Target Superheat? All right, from what I see here, is Target Superheat from the evaporator superheat or compressor superheat? When you refer to?
Yeah, it's actually coming. So it's on the suction line. You're doing your superheat from the suction line. So it's coming from the evaporator to the compressor, and you're checking it. You're checking your superheat to check what you're not taking it from the liquid line. You're taking it from the suction line in cooling mode.
Okay, very good. Let me expand these here. All right, can you manually enter the outdoor temperature if you only have the Testo scale and valve with the app?
Okay, yes, you can. So if you're referring to Target Superheat, absolutely, you can manually enter the information for Target Superheat. Absolutely, you can do that.
Okay, and I'm gonna go with one more here. Are our Testo refrigerant products A2L rated?
Yes, they are. They're completely rated for that transition to those refrigerants. So there should be no issue there. We have a certificate proving that as well.
Okay, very good. Now there are a few additional questions here, but we are running out of time right now, but I will be forwarding these questions on to Leon, and he will be able to answer them within the next couple of days. And once again, thank you for joining our webinar. And this is just a reminder that today's training is part of our summer webinar series. If you are looking for more detailed information on our products and services, please join us for one of our upcoming live webinars. The links to sign up for these sessions will be included in follow-up emails from today's presentation. And once again, on behalf of Testo, we would like to thank everyone that attended our session. Thank you, Leon, for your fantastic webinar on using Testo AC product portfolio to achieve Target Superheat. Thank you, everybody.
Thank you, sir.